Hi, today we're going to do lesson 5-2, fractions and decimals. Now, fractions and decimals are both parts of numbers, and you can write a fraction as a decimal by dividing the numerator by the denominator. Okay, so with 5/8, we do 5 divided by 8. And the way we write it to do long division, we put the 5 on the inside and the 8 on the outside. And when we do that, 8 won't get into 5. We add a decimal and a 0. 8 goes into 56 times. That makes 48. We subtract and get 2, bring down a 0. 8 goes into 22 times. That's 16. Subtract and get 4, bring down another 0. 8 goes into 40 5 times. That's 40, and you wind up with a remainder of 0. That's how you know you're done. 0.625. This is what we call a terminating decimal, because we eventually wound up with a remainder of 0. To write a terminating decimal from a fraction, you do what we just illustrated, which is you divide the top number by the bottom number. Okay? Now 4 doesn't go into 1, so you have to add a decimal and a 0. Extend that a little bit. Okay? 4 goes into 10 2 times. 4 times 2 is 8. You subtract, you get 2, add a second 0, bring that 0 down. 4 goes into 25 times, and that does equal 20, which means our remainder is 0. Put our decimal point on, and there we are. So, a digital scale would read 0.25 if you get a quarter pound of potato salad. Okay? Now on each of these, we're going to do the same thing. I'll do the first 2, and then I'm going to ask you to pause the video, so be ready for that. And then I want you to work the other 2 out on your paper. Then you hit play and see how you did. Okay? So, 3/4, you put 3 on the inside and 4 on the outside. Add a decimal, we'll add a couple zeros there. Okay? 4 doesn't go into 3, 4 goes into 37 times. 7 times 4 is 28. Subtract, you get you get 2. Bring down your extra 0 there. 4 goes into 25 times. And 4 times 5 is 20. So we get a remainder of 0. The answer to that one is 0.75. Our second one is a mixed number. So we're going to deal with the fraction, and then we're going to add the 1 on before the decimal point. So we have 7 divided by 8. Add our decimal and a couple of zeros. I'm going to need 3. I just happen to know that. You might have to do trial and error. Okay? 8 goes into 70 8 times. 8 times 8 is 64. When you subtract, you get 6. Bring down a 0. And 8 goes into 60 7 times. Multiply 8 times 7 and get 56. Subtract and get 4. Bring down your third 0. 8 goes into 40 5 times. 8 times 5 is 40. So you get a remainder of 0. 0.875 is 7/8. But we're talking about 1 7/8. So our answer is actually 1.875. Okay, our whole number goes right there. You don't have to do anything with it, but stick it before the decimal point. At this point, I would like you to hit the pause button and then work out this problem and this problem. When you have them both complete on your paper, press play again and see how you did, and the answer will be there. You should have received, or you should have gotten, 3.3 for 3 3/10 and 0.6 for 3/5. Okay, a repeating decimal is when you have the same digit or set of digits that repeat over and over and over again. You can have 0.3333333 forever, or you can have 0.342342342. Okay, so sometimes it's one digit, and sometimes it's more than one digit. To write a repeating decimal from a fraction, you do exactly what we were doing before. You divide the top by the bottom. So you put the 2 inside and the 3 outside, okay, and you divide. 3 doesn't go into 2, so you add your decimal and your 0. 3 goes into 20 6 times. 3 times 6 is 18. You subtract and get 2. Now I want you to notice at this point, and it might take you an extra step or two to figure this out, but my remainder here, I'm ready to add a 0 and bring it down, but it's the same number I started with, which means that the answer I've gotten so far is going to continue to repeat. Let me show you what happens. You add a 0, you bring it down, 3 goes into 20 6 times. Oops, not 20, 18. Subtract, you get 2 again. Notice you got that again. That means this number, this 6, is going to repeat. So 2/3 is 0.6 repeating. I want to be careful if you're dividing on your calculator. Your calculator display will, on this one, will probably read 0.666666667. And that's because when your calculator runs out of room, it rounds the last digit. So even though there's a 7 at the end, it really is 0.6 repeating. Okay, let's work this one, 15 over 11. So that's 15 divided by 11. 11 goes into 15 once. This was an improper fraction. Subtract, you get 4. Add a decimal and a 0. Bring that 0 down. You've got 40. 11 goes into 40 3 times. 3 times 11 is 33. Subtract and you get 7. Not the same number. 4 and 7 are not the same number, so I add a 0 and I keep going. 11 goes into 70 6 times. 6 times 11 is 66. When I subtract, I get 4. This is where you see the repeat, okay? You got 4 when you subtracted here. You got 4 when you subtracted here. Well, what's going to repeat? Is it going to be 136136? Is it going to be 1363636? Is it going to be 1366666? Let's add one more 0 and see what is going to repeat. So we add another 0. We bring it down. It's 40. Okay. 3. Aha! It's going to be 363636. When we subtract, we get 7, which again, we would come up with 6. So 15 over 11 is 1.36, and the 36 repeats over and over again. Okay, I would like for you to work all 4 of these problems. So you're going to need to pause the video, and you're going to need to work out all 4 of these problems, then press play. Now, when you press play, the answers are just going to pop up, so I want you to be sure and hit pause right now. Okay, 7/9 is 0.7 repeating. It's a repeating number, and 7 is what repeats. That's what this question asked. Okay, 21 over 22 is 9.54 repeating. It is a repeating number. 5/4 repeats. 11/8 is 1.375, and it is a terminating decimal, so nothing repeats. 8/11 is 0.72 repeating, and the 7/2 repeats. Hey, putting numbers in order from least to greatest, the first thing you should do is put them in decimal form. Then you should put them in order. I would like you to hit pause on your video and work these out. Get them in the correct order, then press play to see how you did. Okay, first thing we did was turn them all into decimals. 0.25, negative 0.2, negative 0.6, and 1.1. Then we put them in order. Negative 0.6, negative 0.2, 0.25, 1.1. Then we put them back in their original format, negative 3/5, negative 0.2, 1/4, and 1.1. When you do ordering of decimals and fractions, put them all in decimal form, put them in order, then put them back in their original form. so that we know what the correct answer is. Okay, you can write a mixed number as a fraction, okay, or a decimal as a fraction. Okay, the 1 is going to just be 1. So we're going to deal with just the decimal part, 0.12. 0.12 or 12 becomes your top number. Okay, it says determine the place value of the last digit of the decimal. The 2 is in the hundredths place, so your bottom number is going to be 100. Now some of us get a little confused once you're past the decimal point on your place value. So another way to do that would be to say there are 2 numbers after the decimal, so there are 2 zeros on the bottom of this fraction. Once you've got that, you simplify. Now to simplify a fraction, you can use our factoring ladder, just like we did for finding least common multiple and things like that. So we put our top number and then our bottom number. We say, okay, look at that, they're both even. So we pull out a 2. That gives us 6 and 50. They are still both even. So we pull out another 2. That gives us 3 and 25. 3 and 25 do not have any common factors, so our answer is actually 3 over 25. So your factoring ladder is really useful in simplifying fractions. Now, I will not be showing you the factoring ladder for the rest of our fractions that we simplify. I will just be giving you the simplified answer. To figure out how to do that, use your factoring ladder. That's the easiest way to simplify. Okay, I want you to do all 3 of these. Oh, wait a minute. Let me go back. 3/25 is just the 0.12. I forgot to add the 1. It's really 1 and 3/25 because of this 1 right here. Now we'll go back to this other page. 1.75, 2.32, and 0.65 are the 3 decimals that I want you to turn into fractions. So press pause on your screen right now and work those 3 out by yourself. Okay, how'd you do? 1 and 75 hundredths, 1.75, 1, 75 over 100. 75 over 100 simplifies down to 3/4. 2.32, 2 and 32 100ths. 32 100ths simplifies to 8 over 25. And the last one, 0.65, is 65 100ths, which simplifies down to 13 over 20. Okay, we're writing a repeating decimal as a fraction. It seems kind of odd. Like, how would we do that? Because there's an infinite number of decimals after the decimal point, right? Well, you're going to write the decimal in a equation. I'm going to have to just show you how you do this. It says here, form 2 equivalent equations by multiplying a power of 10 and then subtract the equations. And you're saying, what? So let's look at this. 0.72 repeating. So the first thing we do is we assign this a variable. X equals, I'm going to leave a little space here and you'll see why in a second. 0.72 repeating. Now remember, 0.72 repeating means 0.72727272, okay? And it keeps going, dot, 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 keeps going. I hate when my dots connect. Okay, so how many digits repeat? 2. So I'm going to multiply my x by 100, okay? 2 decimal places, 2 zeros. 100 times x is 100x, right? When we multiply 0.72 by 100, we move our decimal 2 places, right? Okay, so this becomes, let me go back to the color, oops, the color I was using. So this becomes 72.72, and the 72's repeat here also. Even though we moved our decimal over, they still continue to repeat. When we subtract this equation from this equation, you get 99x, because you had 100 x's, you took away 1 x, you have 99 left. And over here we just have 72, because 0.72, 0.72, 0.72 forever, and then you subtract 0.72, 0.72, 0.72, all that forever. They cancel each other out, and you wind up with just 72. Now, what's happening to the x? It's being multiplied by 99, so we divide by 99. And 72 divided by 99. Okay? Then we simplify that. 72 over 99, which simplifies down to 8 over 11, because they're both divisible by 9. So 0.72 repeating is 8/11ths. And if you don't believe me, take 8 divided by 11. You're going to get 0.72727272. Okay? Now, what we multiply by, I'm going to reiterate this. What we multiply by depends on how many decimal places repeat. So we've got 2 decimal places that repeat. So we have 2 zeros here. Okay? So just at a glance, this one's going to be times 10. This one's going to be times 100. This one's going to be times 1,000. Okay? So this will be 10x, 100x, 1,000x. Okay? I'm going to work this one out, and then you're going to do these two by yourself. Okay, so we're going to have 10x, and we're going to have x. We always have x. X is what we started with, 0.7 repeating. Okay? 10x is, you move the decimal point over. It's 7.7 repeating. Subtract those. 10 minus 1 is 9. 9x. And as 0.7 repeatings fall out, 9x equals 7. Divide by 9. X equals 7/9. Okay, I want you to hit pause on your video player. I want you to work out these last 2 problems, and then I want you to hit play to see how you did. Okay, how'd you do? For 0.54 repeating, you should have gotten 6/11. It's originally 54 over 99. They were both divisible by 9. For 0.213 repeating, you should have gotten 71 over 333. It was originally 213 over 99, but they are both divisible by